All neurons, or nerve cells, consist of a cell body, an axon, and one or more dendrites. Dendrites receive signals from other cells and carry them to the cell body. The axon carries signals away from the cell body and toward other cells. The nervous system carries signals through the body in the form of nerve impulses. A nerve impulse is a wave of chemical and electrical change that moves along the membrane of the nerve cell. Between impulses, the membrane is said to be in its resting state. In the resting state, the inner surface of the nerve cell membrane has a more negative charge, and the outer surface has a more positive charge. This difference in electrical charge across the membrane is called the resting potential. When the nerve is stimulated, channels in that area of the membrane open and sodium ions, Na+, flow into the cell. The flow of these positively charged ions reverses the charge difference across the membrane. The inner surface becomes positive and the outer surface becomes negative. The reversal of charge in this region of the membrane causes channels in the neighboring region to open. Sodium ions flow in and the charge is now reversed in this region. As gates open in one region after another, the nerve impulse moves along the membrane. A few thousandths of a second after the sodium ions enter the cell, other membrane channels open and allow potassium ions, K+, to flow out of the cell. This outflow of potassium ions restores the membrane to its resting potential. This reversal of charge, followed by restoration of the resting state, is called an action potential. Action potential is another name for nerve impulse. Action potentials travel very rapidly along the membrane of a nerve cell. Some move at a speed of 300 feet per second.